Yep. I read your post. So I think I explained that question one, right? I think I highlight that once during the class. But anyway, I'm going to repeat that later. So don't worry. Yep, good evening. Okay, so let's check our attendance. Thank you for those who helped me to click on the recording. Okay, thank you for that. And yep, good evening class. Okay, I hope you have some things with you. I mean, it's already take some things for your pre-dinner. Okay, but again, as I promised, I wouldn't drag you long for today's class, right? Once I deliver what I wish to let you know, and I can let you go. Okay, so just a quick one. So today is week 12, 22nd, right? And we have gone through the chapter 6 last week. Last class on Monday. We already completed, am I right? So perhaps after today's class or next class, I'm go through some exercise for the chapter 6 first before I touch on chapter 7 and chapter 8. Which all this is not in your syllabus, don't worry. What means by not in syllabus? It's in your syllabus, but I'm not going to ask a question for this, just to add on information for you all. Okay, so for today's class, I will focus only on the revision and the thing you must know. Okay, so hope you have get ready for your test 2 on next week, not Monday. Okay, and again, I strengthen again. If without a solid reasons, I wouldn't give you any replacement. Okay, I wouldn't give you any replacement. So don't miss your test. PM to 9:30 p.m. For sharing. Yep, don't worry because today I want to focus on the test too. Yep, if you learn that is good. Okay, if you learn that is good. But I want every one of you learn by yourself. And then definitely I'm going to go through that. So don't worry on that. Okay. Oops. Are you rushing home now? Can you hear me? Where are you going? Sen Nong. Anyway, yeah, can you hear me, Where are you going? Anyway, that's why these are things I know. I think he bugs down. So yeah, I think he didn't turn on the video anywhere, whatever. Okay, again, yeah, I don't really wish to see this kind of things, to be honest, right? If you got some things, let me know you're going to join it or whatever. Okay, I'm totally okay for that. But please don't join it and leave it at unattended. It really gives me a very bad impression on that. Sorry to say that. But anyway, if you got any emergency, anything, please let me know in advance. Okay? I'm not the kind of things that you didn't come, I penalize your attendance or whatever. Never, isn't it? Since beginning until now. If you got something, which is reasonable or whatever, I always to accept your reasons. Okay? But anyway, I wouldn't turn around that. So where did we stop? Yep. So regarding the calculator, yes, you're still given some time to try. So next class, I'm going to show in the class as well how to use your calculator. Thanks for sharing. Yeah, how to use a calculator to calculate your what is that formula called? Cox-Brooks equation. Okay, but today's class, as I mentioned, I want to focus on the revision for your test 2. Okay, so for your test 2, again, it's a Malaysia time. Don't mess up. It's 8 p.m. until 9:30 p.m. at the night. Okay, not mornings, night time, p.m. Okay, and you're given extra 30 minutes for submissions. Okay, since you have already gone through the test 1, all the mechanism will be exactly the same. So don't worry about that. So You just need to be focused to answer your question. And since you all know what is my style right now, right? So I do hope that try to write as clear as you can. Don't jump step. Yep, 26 July, a Monday. Okay? And don't jump steps. And more importantly, don't go and Google or don't go and search here and there to copy the answer. Okay? As I mentioned, I won't give you any chance this time. Okay? So please don't disappoint me. Because if I see any parts of the paper is resources from somewhere, I know where you can get it. As I said, there's a lot of different way you can get it. But if that's the case, I assure you, you will get 0 for that. Okay, I take my words. I will definitely give you 0 for the test 2 if you are copying for any resources or whatever. Okay, I won't give any. I already give a very linear for the past few weeks, but I don't hope to see this kind of thing happen again. Okay, so any question before I go through the revision? Anyone got any comment? And maybe before I start, can I know how many of you have started your revision? Yes or no? For your test 2. Okay, good. Thank you. Reasoning, yep. I mean, at least as I said in last class, right? For today's revision, if you have started, if you know what's going on, you know what's the main prince or whatever, okay, you should you can benefit a lot for today's class. But if you know, sorry to say that you might can't follow me very well, because for today's class, just a quick recap for all the things we have been learning so far, and I want to highlight the key information you must know. Okay, so anyway, just be focused on today's class. Okay, so far no question, right? Anyone's got any questions to ask? Sorry. No energy to focus. Anyway, okay. So just a quick recap. So in chapter 4, so the title is Momentum Analysis of the Fluid System, right? So as I mentioned, in chapter 4, generally, the question would be, oops, where's my things? Okay, so since you already gone through the chapter 3, right? The chapter 3 learning that the principles of conservation conservation of the principal mass, or conservation of energy or whatever. In chapter 4 is the same things, right? Everything about talking about energy, everything talking about mass, volume flow rates or whatever is still the same volume flow rates. All is still the same idea. It's not going to change between the chapter 3, chapter 4, and chapter 6, right? But in this case, we go for the linear momentum and angular momentum. I hope you can recall all these things, right? And what the difference between chapter 3 and chapter 4 is, most of the time in chapter 3 is static condition. Your thing is not moving, or your thing is already fixed there. You just need to know from point to point. But for chapter 4, we know that all the things is in dynamics. They're moving in the water is flowing, or there's rotating or whatever. There's all dynamics condition. Okay, so under the linear momentums, what is the key formulas we need to know? Just practice yourself, write down what you need to know for this. is the summation F equal to
M dot V.
Beta M dot V.
beta M dot V with this. What else? Anyone?
Out
Yep. Thank
minus.
you. Thank you for that. Yep. It's out. Make sure you know it's out. What I mean out is because it's a moving, definitely there's some inlet and outlets. Uses your outlet energy minus the inlet energy, right? So you have the beta MV out minus summation of the beta MV in. So this is a general information, a general equation you need to know. But of course, go through the sessions, right? We have learned so many things. We learned how to get the beta, am I right? Can you recall that questions? How to do the integrations for your velocity profile to get the beta. We learned how to get your M dots in the chapter 3. Rho V equal to rho VA. And of course, you know how to get the velocity. So in this case, a lot of times when there's only one outlet, of course there's only one. But when there is a pressure inlet or there's a weight concentration, you need to modify your inlet energy. Am I right? Can you all recall that?
Yes, sir.
Yep. Okay, MV out minus MV in. Yep. And please, just to highlight that is make sure it's M dot V, right? I know a common mistake. After your first step, I even sure that some students still not sure what is M dot referring over here. The M dot referring over here is a mass flow rate times your velocity. And this is not volumes, okay? Make sure you're familiar with what all these units stand for. Don't make mistake on that because sometimes when you're confusing, you are very hurry, you just think that, oh, MV, V is volume or whatever, and this is meter or whatever, you just put whatever you want. But I would say that last semester, I do get the kind of answer somehow. Okay, so just a quick recap. So all these things about the theory, you need the Newton laws, first law, second law, third law. And of course, in these momentums, we apply the Newton's second law. And after that, we need to know what is the energy changes in our engineering application. So they use the conservation of momentums principle. This is general information for this chapter. Okay. So from there, I passed the angular first because we are going to go through that later. So as I mentioned over here, when you got the momentums, right? Conservation of momentum. Definitely the case will be put into the linear and angular. And I do explain to you last class what make it different when, because in the question, just for information, in the question wouldn't direct ask you, please calculate me the linear momentums for my case, or please calculate me the angular momentums for my case. When look at the question, you need to identify either we are talking about linear momentums or angular momentums. I think I highlight that in one of our previous class, am I right? So one of a very good example is this example. Am I right? So we've gone through this example. This kind of question can be asked either linear momentums or angular momentums. Am I right? Depends what the question wants. For this case, they want the bending moments. So these keywords give you the ideas oh, I know this is angular momentum. But if the question asking something like anchoring force in between, just like this, my anchoring force determine the gas pressure or whatever, or the anchoring forces needed to hold or whatever inside this system. So all this will lead to your linear momentum. Okay, so that is, so just quickly go back that. So, and as I said, I don't expect you to derive the thing, so don't worry on that. But what do I expect is you need to understand the system. For example, this. Okay. When have you gone through this? Yep, I think we've gone through this, right? But in this case, I want to highlight. In this case, you can see that my pressure gauge 1 and pressure gauge 2 is got the gravitational effects. Okay, so it's pointing down. So make sure you familiar with all the direction of the forces. And not all the time your questions can ignore the gravitational force. Do you get what I mean, class?
Yes, sir.
Yep, so in case you got something like this, so you need to be careful that even though this is your inlet, let's say come in from here and go out from there, your outlet pressure will be a negative value due to the gravitational force. Okay, so these kind of things you need to analyze and understand the condition. But if the question mentioned just like your tutorial question, just like your sample question, ignore the gravitational force or whatever. So of course, all these things will not affect you. You just follow whatever that is. Okay, I'm go through this later on very quick. Okay, so again, just to highlight that all the forces must be a summation. So just like in this case, you got 1, 2 inlets and 3 outlets. So all the things must be a summation condition. Oops. Okay, no question, right? Okay. So continue. And this is a beta I mentioned. So this is the formula you need to aware. And in case your examination asking, this is not given. Okay, make sure you know what is the requirements for the beta integration. For example, in this case, you need to use this 1 over SC integrate V over V average or whatever. So make sure you know what is this and how you get the beta. I think we have gone through the discussion very well. Okay, so again, this is the things I highlight. This is the thing you must know. And why all these things? That's why I know you all have a very, for those who have very strong static and dynamic knowledge, you might get confused because whatever force working here, to obey the momentum equation, everything must obey these rules, which slightly against your dynamics condition, right? And for those who have started, I guess you get what I mean. But remember, always remember to apply these rules when you want to calculate the system energy. Okay, so this is a thing, it's done, and this is a sample we've gone through. So, yep, for linear, is that clear? For the linear momentum, is that clear? Any question you want to ask?
One question. Can you go to the example 1 of the slides? The first example where we used to find the beta. Like I'm only confused about there are two V's. One is V with the vector sign. The other one is also V. I'm like, what are the names? Like I'm not. Yeah, this one. You see, we have two V's at the top. So
Yeah.
which one is what? I'm actually confused. It's all good, but that's my question.
One is a V average, one is a V.
Both of them are velocities.
Yes, both of them is velocity. So what this formula tell you is this hyperbolates of the velocity using the average velocity tell you the whole story. So it's a relationship between the velocity average, how it's moved, and how the radius changes your final velocity. Both
All right,
also
thank you.
velocity. Yeah, both also velocity. But because this V is the overall parabolic shapes, am I right? So they need information of how the things move and how the radius change. So it's a relationship of all these things contributes to your final velocity profile of your liquid. Okay?
Thank you
Did
so
I
much.
answer your question? Yeah. Any other question? Any other question? Will you ask us to find beta? Yeah, I would say anything can happen. If gravity force always is gravity, could you teach us briefly how to calculate if there is? Yep, so that's the case. If the gravitational force is not neglected, so come back to this. Okay, so in this question, maybe I just give a great one. So if the questions, so just assume this non-marks, right? Because this diagram already give you, assume it's not given. If the question asking, I got pressure inlets, pressure inlets is over here, and I got pressure outlets, let's say equal to 10 kilopascal. My pressure outlets equal to 20 kilopascal. Okay, so if the questions mention ignore the gravitational force, so your inlet will be go here and go out. So your P1 gauge will be pointing down because it's inlet this direction. Go out, the P2 will point out. If the question asks you, ignore your gravitational consideration. So second case, if the question didn't mention, you can ignore all this gravitational force. So your P1 will be, as usual, against your inlets. But your P2, when you're going out, your P2 will still pointing down, just like this case, because you need to consider the gravitational force. Do you get what I mean, class? Yes or no, class?
Yes, sir.
Yep, so this is the things, as I said, is an analysis of your understanding, just like your this question. Okay, do a quick one. Right, so for this, what they ask you to ignore. Okay, because it's mentioned going in from one direction, right? And they didn't ask you for the outlet pressure. Okay, they didn't ask you what is my P2 pressure, am I right? If the question give you also my P2 pressure is equal to some value, let's say what the value they're given here. Oops, let's say it's about 20 kilopascal. Okay, and the question says neglects the gravitational force. So your P2 will point it outwards. Okay, so in case they didn't ask you to neglect, so your P2 will point it inwards due to the gravity. Do you get what I mean? class?
Yes, sir.
Yep. So, but again, don't worry on that. So this is a general idea, and you need to understand. So if inward, we assume is negative. Yes. So if inwards, and that's why even though, so don't get confused for that. The key things when you look at this kind of question, you need to make sure you're able to sketch all these things. I think I briefed previously, right? You must able to write all these forces happening around here. If you point it inwards, you just assume it's going this direction negative. So of course, this is a negative value, the input, that's all. And again, you need to use all your static and dynamics condition subjects to, don't forget this, because this one is minus. And I would say that quite a lot of students make mistake over here. Because when this is negative value, minus minus become plus, or minus plus become minus or whatever, vice versa. So please be careful on this formula. This thing makes you confused. But if you're familiar with what is going on, it should be fine. Okay? So, any further question? So if inward, you assume it's negative. Yes, exactly. So since you know that the direction going inside, right? So you just assume negative. Okay? The P only can be neglected if it's same with ATM, right? So yeah, depends on the question. I would say that depends on the question. Whether the questions tell you that is the pressure inlets or pressure outlets or whatever. If the question didn't mention, then you just ignore. Don't put your heads into that. Because sometimes the question will ask you, does a pressure inlet contribute for the forces? So as I briefed early class, right? All the pressure also one of the forces, because pressure equal to F over A, and PA is the forces. Okay, so if no, then it's fine. Don't worry about that. Okay. The P only can located if there is. Yep. Because if the outlet is P atmosphere, so just like your case, you will get a P1 gauge. Am I right? Because your P inlets minus your PFTM is a P1 gauge. I think we learned through this example, right? Just go through again to understand that. But as I said, not all the times, all the things is so nicely arranged for you. Okay, not all the times. Sometimes we just let you know that P1 is certain value, P2 is another value, just like this diagram. Right? It's give you directly what is my value for that. So how you're going to calculate that is totally up to you how to put this in a way that comply with the formulas. Okay, so let's go through the example. So in this case, I think for this is no issue. Oops, maybe I just open my answer as well. So just we go through, and I hope you have tried all the questions, right? And that's the only way can strengthen your understanding. There's no shortcuts. Okay, so for the question 1, I think it's no issue because it's again your momentum flux question. How to use this to derive, not to say derive, to get your, where's my thing? Okay, how to use your velocity profile to get your momentum flux. So as I said, right, the question can be asked in a lot of different ways. For example, section A, please get me the momentum flux correction factor by using certain value or whatever. After that, you can ask you to use the beta into the following question, just like your question 2. And sorry for my mistake for the question 2. Yes, you are right, some of the students. If you solve the question 2, you realize that, and also this mistake is a 90-degree bend. Okay, it's a 90-degree tangent. So you got all the diameters, radius, velocity, and in this case, you got the P1 gauge. Okay, you got the P1 gauge enter your pipes. Okay, and the tricky part for this question, the inlet of the band is 70 cm above the acid. Supposedly, when you look at this, what you need to do? Bernoulli equation, am I right? When you look at this, I got the potential energy. Oh, where's this? When you look at this, I got the, where's the thing? I got the inlet bands is 70 cm above the acids. That is a 70 cm between in the height. Am I right?
Yes, sir.
Yep. And in this case, why my answer is not included? That because the question asks you to neglect all these frictional and gravitational effects. But I would say that this is just a tricky of the question. And hence, that's why you don't have to consider this 70 cm because your gravitational won't give you any effects further on this height. That's why you just assume that it's just a smooth flow on that. Okay, and then you just use the formulas to get your Fs and Fy. But that's right, that I forget to put in your pressure one gauge. So in fact, your Fs, you need to consider you have the pressure inlet, and then you should be able to get the answer. Is that clear? And
Yes,
that's
sir.
why, yep, and I need a lot of communication in the groups where I don't see much, right?
Sir,
Yep.
here for this question, we can see that you have used the m dot. It is the same for both inlet and outlet, right?
Yep, because this assume the mass flow rate is constant, is given by the text. That's why all the flow rate in this condition is similar.
Yes, so that's why firstly I had the idea of the Bernoulli equation, but then I saw that you did this directly, not using the Bernoulli equation.
Yeah, because this case is due to I don't have to consider my gravitational effects. I don't have any potential. In case this question change, not asking you to neglect any gravitational effects, yes, it will be similar as question 3. You solve question 3, right? So the question 3 will have a Bernoulli equation. So the idea is just the reasons the question I said in this way, I want you to identify how tricky the question can be asked. Okay, how tricky the questions can be asked. Because the question can be asked in a lot of different ways, end up your methodology and your answer is slightly different.
Sir, one question.
Yep.
So when they say neglecting any gravitational effects, means there's no need to consider the elevation. And when they say that no need to consider the frictional forces, frictional effects means no need to consider the gauge pressure, right? Something like that.
No. This one you need to consider the gauge pressure. It's my mistake for the answer. So you no need to consider for this evaluation. This right? That's why I written here. Oops, where's my answer? Because ask you to neglect the frictional force. That's why your 70 cm height is neglected. You don't have to consider that. That's why I didn't use the Bernoulli equations to solve this. But because you got the inlet of 280 kilopascal, so you need to from here, you need to minus, maybe I new one. Okay, So your summation, because it's the angular force, right? Summation Fx equal to summation out beta mv2 minus summation in beta mv1. Okay, and you don't have any outlet forces. Because why you don't have any outlet forces? Because you don't have any horizontal force anymore, am I right?
Yes,
Just
sir.
this diagram, you got only one horizontal, one vertical. So your R is 0 minus your 1.10, 76.9, which is already in there. Don't forget, so this is a mistake for that, right? You need to plus your pressure outlets. I mean the pressure inlet, P1 gauge. In where your P1 gauge is 280 kilopascal, am I right? But you are not adding this, but you adding P equal to F over A. You need to P times A to know where's the forces here. So P1 gauge with the area. So give you the final answer for that. It's okay.
Yes, sir. I did exactly like this for my one.
Yep. So once you get Fx, different value, of course, you get a different Fr by using the formula. And also you need to add in the angles. So don't forget for that. They will carry some marks as well. You know
So
how to
we
get the
need,
angles, right? Because once you get the, oops, this is the thing, Fy, Fx, and here is your Fr. These angles you need to include all the time as well. I think it's just same like your question 3 later on. Yep. Is that clear? Oops, where's my...
sir, question 3 doesn't include any angles.
Yep, that's why I said you need to include that. Because during the class, I think I explained to you, right? Even though the answer given is not include anything, but please include this. It's a package for you to get the resultant force with the angle. This is normally what you learn in dynamics, am I right?
Yes, sir.
Okay, so question 3, I think is an example. You see the answer given is don't have the angle, but please include that. I think during the class I do explain on that, right? Please include the angle as well. Okay, so that's a part 1. So for part 1 it's okay. For the linear one, it's quite straightforward, am I right?
Yes, sir.
Okay, so any question, class? Are you with me? Pressure at outlets should contribute to the overall resultant force. No, the pressure outlets should contribute to the MV2, the outlets. That's why you got the formula for the MV out and MV in, right? If the outlets, that's why you contribute over here. If the inlet is contribute over here. So please be careful when you apply into this formula. Okay? Stephen, did I answer your question? Yep. Stephen, are you there? Oops. Am I muted, class? Yep. Okay, good. Thank you. So that's about the linear. Okay? So about the angulars. So as I mentioned again, in angulars, idea is the same, right? The overall idea is very similar to your linear momentums. If you understand,
Sir,
yeah.
one question: you want the angles in degrees or radians?
Doesn't matter. As long as you show me you know how to find the angle, that is fine. But of course, most of the time you put in degree, am I right?
Yes, sir.
Yep, so either way is fine, so don't worry on that. But just need to show me that you know that's the angles of the resultant force as well. Okay, so come back to this angular. Again, as I mentioned, the key things you need to know, we'll go through this first. Key thing you need to know, of course, is this formula, right? So make sure you're familiar with this. All the angular momentums talking about this. Rm dot v minus Rm dot v. So the key things, idea is still the same. Energy changes in your system, right? So how this changes, and I would say the idea is not difficult to understand, but the thing is your positive and negative sign will make you very confused. And that's why I mentioned, right? If you're not really sure on that, you need to revise all the static and dynamics fundamental to make it happen, right? Because as I mentioned, in this case, fluid mechanics only teach you this. But again, all these things is your fundamental, all the forces direction, how the force go here and there is the fundamental of your statics or dynamics. Okay, so this is the thing you need to know. And this is just another thing, no, this one. Omega, as I mentioned, not all the time the question will give you omega, or the question either will give you RPM or whatever. They can ask you in a lot of different form. Since you have gone through so many, right? That's why you know the final format is RMV. But in case they are not giving you any of this information, where do you get this? Sometimes they give you omega, sometimes they give you RPM. You need to know how to get all this information. Finally, contribute back to your equation of this. I think we learned during the class, am I right? Can you recall class?
Yes, sir.
Yep. Okay, so that kind of thing is very important. Okay, so after that, that's all for the linear momentums, not the linear momentum, sorry, angular momentums. But what add on for this is the special case about the radii flow device. Because in this case, it's a combination of your angular momentum and also linear momentums. But this is a formula as I mentioned previously, right? Make sure that you know what is your volume flow rate for this case. We are talking about the cylinder's cross-section area. Okay, but anyway, at the end, as I said, we still obey this thing. Why this thing happen is because the question can ask in a lot of different way for you to get the information you want to fit in. Okay, because I would say that the question won't tell you exactly this is my V given to you. My V is talking about 10 meters per second. No, there's no chance. All these V you need to source from somewhere, where they come from. For example, this case, I give you a volume flow rate, then you need to get me what is my velocity. Or I give you omega or whatever, how do you link back to my mass flow rate or whatever. So all these things you need to know. Okay, and as I said, at the end, the question might ask you to calculate what is my shaft force. So this is very important for the chapter 4. Okay, so this is the two examples we've gone through. As I said, for this case, it's because the question wants to measure the bending moments on the point A. That's why all the things change into the angular momentums. In case if the question not asking that way, it will be very similar to your question 2, am I right? One inlet, one outlet. I want to know only the angular force Sy, Fx, and my Fr. So the question can be tricky, right? But in this case, they want to know the bending moments for this. Hence, all the solution, I think we have gone through very details. I already briefed you why there's a positive can change negative or level. I hope you revise that. Okay? And this is the reason all these things, how it's happened. Okay? And second case.
Sir?
Yep.
Yes, I have one question here. I understood everything, how everything works, but I don't understand the concept. Why we are subtracting the nozzle velocity from the jet velocity? I tried it a lot. Like I know how to do it, but I don't know why it's minus.
Because it's a net force, as I mentioned, right? I think I explained this as well, am I right? So in this case, you're talking about here, right?
Yes, sir. Like I saw your recorded video, but still I was not
V jets
clear.
minus V nozzle. Why
Yeah.
do you need to write?
Yeah.
Because you got something spreads outside. Again, I just explain again. Okay, you got something velocity spreading outside. Due to this spreading, your thing is moving backwards. Okay, so this V jets is getting your net velocity or net resulting velocity. This is the velocity contributes to the whole system energy. Do you get what I mean?
So as the water goes out of the jet, the water gets a backward force, right?
Yes.
So that makes the velocity of the nozzle.
Yes. That's why over here you use the net velocity to calculate what is the shaft energy available.
Yes, sir. Clear, sir. Thank you, sir.
Yep. So, yep, I think that's all. So this is the idea for that. And if you've gone through these two questions, really understand what's going on, and I would say it should be fine. Okay, I would say it should be fine. So go through your distance. First question, two questions is the same. I hope you redo that. I will just go through the question 3. Okay, so your question 3. And just let me see, what is this? Okay, and don't worry on that, because in this case, you don't know what is the pressure, am I right? So the answer is using rho RT, which you learn in your thermodynamics. If this kind of question asking during the examination, I make sure this kind of formula is available, will be provided to you. But more importantly for this is to know what is your shaft energy contributes to your thoughts. So you have this MRV, is that too small? So RV2, R2V2 minus R1V1. Okay, because you got the propeller turn-ins. So from there, you can use all the formulas I mentioned just now in this page. It's totally, when you talk about the radii flow device, okay, this is the information you must know how to do that. Because from all these things, you can know what is the contribution of the thoughts. And after that, you can easily get the velocity or shaft power of level. Helps, yeah. How to identify which one is R1, B1, R2, B2? Okay, you means for this B2 or V2, are you mentioning it? Okay, so let's go through the question. Okay, because you got the inlets and outlets, right? So generally, your inlets will referring to the case 1, R1, V1. And your outlets is R2, V2. So this is how they define. Anyway, yep. So R1, we uses R1 and R1 V1s and R2 V2 to represent the in and outlets. So this is the case. So when you look at this, it's using your outlets minus your inlets. So from here, inlets at 15 cm, outlets at 30 cm. So the idea would be like your summations of the moment. Okay, so you try on that. So in this case, ask you to calculate what is the velocity for that. And have you tried the question?
Yes, sir. Sir,
Yeah.
one question. So this one, like there was no density given, so I had to see your solution then solve.
Yes,
So,
yes. That's why, as I said, this case, because they're asking you to use the different pressure, which is thermodynamics. In case if this one asking in the examination, I make sure the formula is provided, or I will let you know where's the density.
thank you so much, sir.
Okay, so because this one is somehow slightly out of your scope, but anyway, if the question asks, and I make sure the density is there. Okay, because you just lacking of the density information for you to go forward. Else, other things still the same. Okay, so that's all for chapter 4. Any question? And to be honest, I forget the question has been set previously, and I forget either linear or momentums. The question asking, I didn't really go and check it, but I would say that definitely within the syllabus, and you know what is going on, you should be able to solve it. Okay, any questions you want to ask?
No, sir.
Okay. If the tubes is half circle, we use linear or angular. And Nicole, I didn't really get what you mean. How the tube is half circle, and I didn't really get what you mean. Maybe can you further explain to me or elaborate?
Actually, I just had okay lah. No, just like this. If the question is like now we are talking about if the tube is half only like this one, then it should be using the linear or angular.
So it depends on how the question asks. If the question want to know where is my anchoring force, Fs or Fy or whatever, for this case, definitely they're going to linear. If the question wants to know my moments happens at this point.
Oh, okay. It depends on okay.
Yep, then it will become angular, am I right?
Yeah.
Yep, so that's why I said you need to understand how tricky the question can be asked. As I said over here, this question can be asked in linear as well, just like your example 2. Just like your example 2 you solve over here. Because it's just like exactly the same thing, 90-degree bands, and I'm just want to know the net resultant force or whatever. Because for this case, it's purposely asking for bending moment for the point A. So you have no choice to go for angular. Yep. So did I answer your question?
Yeah. Thank you, sir.
Okay.
Thank you, sir.
Yeah, no worries. So again, revise, and revise. That's the only way. Okay. And not much extra information I can give at the moment. Yeah, sorry for that. So any further question for the chapter 4 before I proceed to chapter 5? Chapter 5, I would think, is very simple and straightforward. It wouldn't take more than half an hour or whatever. Any question for chapter 4 before I proceed? Okay, so silence. Anyway, okay, if no question, I will proceed. So in chapter 5, so as I mentioned, in chapter 5, you learn only 3 things, am I right? What is the 3 things I highlighted? Can someone let me know?
Sir, there are 6 steps for the Buckingham-Pi theorem.
Yep, Buckingham-Pi theorem is one of it. But in the whole chapter 5, we learning only 3 things, am I right? If you can recall what we have learned, chapter 5. We only highlight things, 3 things. What is the first one? Dimension homogeneity. Am I right? To prove your equation got the similar dimensions, dimensional homogeneity. Second is your non-dimensionalization. But in this case, as I said, the limitation for this is the question must be easy enough for you to divide by themselves, get your dimensionals. And as I mentioned, this rarely happen because this is not practical. And finally, you learn the Buckingham-Pi theorem. And can I just ask you to revise again, get your paper, 1 minute, write down the step, please. 1 minute, write down the step, please. Okay. So your step would be, first, identify all the parameters. If I write down right with you. First step. Can you recall how many steps? That's more important. For those who are not responding,
First, we have to find the total number of parameters n.
Okay. For others, are you sure? 5 steps? Only 5 steps? Are you sure? But anyway, that's a 5 or 6. Yeah, 5 or 6 depends how you read that. Okay. First, I will call it the n. Identify. Not to say identify. Write down all the parameters. Okay. Second step. Where's the second step?
Find j.
Yup. Get your j. Identify all the main parameters. For example, you got the M, L, T or whatever. Depends on your given symbols. Wait, third step?
Find k, constant k.
Yep, get your k, number
the number of pi.
And what is the formula for this?
N minus j.
K equal to n minus j. Okay, I hope every one of you can recall this, right? So first step, second step, third step. 4 steps.
Choose the j repeating parameters.
Okay, j repeating parameters. So I have highlights in the class, right? How many parameters you need to choose based on the number of j? Which one to choose? As simple as you can, right? Because I think if you try the question, you know what I mean. Because at the end, you need to write down all your pi 1, pi 2, and pi 3, etc. Okay? In order to write this, you need to make sure that pi 1 equal to something A1, something B1, and something with non-repeatings. And then pi 2 happen again, pi 3 happen again. So once you get all the value for this A1 and B1, substitute back to get your pi value. So this is what you did, am I right? And finally, that's a step 6. So the step 6 is quite critical. If you can recall what I mentioned in the step 6, there are 2 possibilities. 1, the question asks you to prove my formulas in that format. So you can rearrange all the things, pi 1 equal to pi 2 divided by pi 3, or pi 2 plus pi 3, whatever. Rearrange all the formula to fit into the given formula. If the question didn't ask you to prove, didn't show you what is the final format, you can always allow to write in pi1 equal to function of pi2 and pi3 or whatever. Can you all recall this?
Yes, sir.
How many of you couldn't recall this? 6, yeah. How many of you couldn't recall this? So I would say that this is really important, okay? Please make sure you know this. So, yeah, recall goods, yeah. For others who are not respondents, can I get some feedback, please? Are you with me? Because again, as I said, you need to revise that. I know for today's class, I go through it like a rocket. That's why this is the reason why I urge you, you must do a revision, else you will have a difficulty to understand what I'm telling you today. And I'm think that, and I'm confident that for those who have revised, you totally agree with me. What I'm doing right now is, you need to already know that in order to understand what I'm telling you. Okay, good. So for those who have already done, and for those who are not responding to me, I hope you get my message well. Okay, and if you are not started any revision, please start immediately after today's class. Okay, and so we go through the question. This is not important. I directly go through the Buckingham-Pi theorem. Okay, in the Buckingham-Pi theorems, so we have gone through the question 2, right? We have learned how to use that method. That's why this is proven. Ask you to prove in this format. If you can recall, we got the format we want if pi1 equal to overturns the thing. Am I right? Let me write for you.
Yes, sir.
So what you get for that is, if you can recall the answer we have, you get pi1 equal to RE. However, your pi2 you get is rho over mu over rho VL. Okay, so in fact, if the question didn't give you this, you can write your answer as RE equal to function of mu over rho VL. It's fine if the question not asking you to put in this way. But the question asks you to prove it. That's why there's no choice. You need to put pi1 equal to 1 over pi2. And I explained to you why. Because what the Buckingham-Pi theorems tell you is only to get the dimensionless equation. But they didn't tell you what is the arrangement of the formula, unless they specify ask you to prove it. So in this case, they ask you to prove it. You will get this RE equal to rho VL over mu. For example, question 1. I think I explained in class as well. In question 1, the question didn't ask you to prove what is the final formulas for this leaf coefficient. Am I right? So what you get, let me show my answer. I know there's some confusion, but I thought I have explained in the class, but no worry. I will repeat again now. Okay, so have you done, if you've done all the step 1, step 2, step 3 until the end, okay, you get this. You get this CL equal to F, FL over rho V square A. So for those who have solved, you're able to get this, am I right? Yes or no, class?
Yes, sir. But your and my equation is a bit different.
Yeah, but anyway, so this is a function we have. Yeah, it's a function. We have the relationship between your coefficient with my pi1 and pi2. So when it comes to the question 2, why I use this formula? Because I search online. That's why I mentioned in the class. In part 2, you need the exactly formulas for you to solve the question. Because for this one, as I mentioned, this is not the final format of the formula because you don't know what is the exactly formula. But of course, during the examination, don't worry about that. If I want you to prove for any numberings, I will give you the final formats to use the standardized formats. But in this case, I get it from online. I know that my leaf coefficient equal to FL divided by half rho V square A. So I just substitute accordingly and I'll get the answer for this. Okay, so is that all right? I think I mentioned in the class, ask you to solve, get the answer, right?
Yes, sir. So in case we need to find
No, of course,
the
during
value,
that,
you will give us the formula.
yes, so of course in the examination, I didn't expect you to search Google because you are not allowed anywhere. So in case any substitution value, generally the question will be asked you to prove first. Prove you're able to get the formula first, and then to ask you to substitute the value to get what you want. So that is the process. Okay?
Thank you, sir.
Is that clear at this moment? And of course, in the question 3 and 4, you can search through my answer because I would say that is anyway for the whole Buckingham Pi theorem, everything is about your steps, and I think I got a mistake in somewhere for the last question. Am I right? Yep, I think I got a mistake for this because the reasons I highlight this, if you put one of the wrong dimension, the whole things will go wrong. And I would say that, yep.
One thing for the t, yeah, for example, for the t I put as like I used a parameter, but here you use dimensionless. So I
no,
changed
this is my mistake. This is my
oh.
mistake. So just for this is the tricky part I put in the answer. If you have done it, you should aware of this. That's why I want to highlight that if, for example, in second step, you put wrongly for one of these, your whole things will be ruined. I won't let you all know that how serious is that. That's why please double check or triple check your answer. Because for chapter 5, either you score full marks, full 20 marks to get, that's all. And if you make any mistakes, I will tell you that you are going to lose quite a significant marks here and there when you put wrongly for the things. So I urge you, when you do the question, chapter 5, please double check or triple check. There's no mistakes or there's no error or whatever. So if your answer is pi equal to x divided by lambda, I get pi equal to height divided by x. Stephen, I didn't get your questions. I didn't. Which question are you referring to? Which question are you referring to? X divided by lambda and pi equal to lambda divided by x. You mean that? Am I right? Or is a height? Why suddenly got the height? It's of course. If is a lambda divided by x is fine because as I said, you might not choose the similar repetitive parameters as I. So don't worry on that because your pi can be overturned all the time. Am I right? So that's the thing. You can either the pi equal to x over lambda or pi equal to lambda over x. It doesn't matter because what I'm going to mark in this specific chapter. Okay, what I'm going to mark in this specific chapter. Chapter 3. Question 3. Oh, you mean the whole things divided overturn? Yeah, it's fine. If you got overturn, it's fine. Don't worry on that. Yeah, it's fine. But why you got? Oh yeah, it's fine. It's right. It's okay. Don't worry. Just check it. And as I said, this one can be overturned as well. Pi 2 equal to rho v squared L over sigma or whatever. Depends on what's the repeating parameter you put. Because if you select a different from mine, definitely you are going to have overturns or slightly different arrangement of mine. But please bear in mind, the overall things must be able to rotate into the form I have. So this is the tricky part for the question, chapter 5. So just like the question 2 just now I mentioned, you can always rotate your answer to fit in whatever they want. Oh, what is the question 2? Like this one, right? You can get, and some student, if you select the right one or whatever, you can get a directly pi 2 equal to rho VL over mu. That's possible for that as well. Okay, so I think that's all for today. Any question?
Sir, one last question.
Yeah.
For chapter 5, sometimes it's confusing that is the main parameter like there's this function we is equal to f, and also it's sometimes confusing that whether it is dimensionless or not. Like in example 4, I thought it was t, but then again you made it like just giving an example, like how to know that are the parameters dimensionless or not.
Okay, so you need to read the question carefully and you need to strengthen your basics. For example, question 3. Okay, I give you a trick. Okay, question 2. Reynolds number is the ratio between. When you look at these keywords, ratio between the things, you know this is referring to dimensionals. And Weber number, it represents the ratio of something. You know your Weber number is dimensionless. And this is the periods of oscillation. What is period of oscillation?
It is time t.
Yep, that's why you need to put t. But what my answer putting in is dimensionless. And you should fill in some not right, am I right? So that's why again I ask you, and all these things, I can't let you know that what is this because you need to, all this is a fundamental. You need to know the density is certain, as I mentioned in last class or in previous few class. Density, you need to know is a formula for that. Wavelength, depth, gravity, surface tension, and then some, let's say, your viscosity. All these quite common dimension, you should aware of that. This is only things I can say. So that's why my suggestions, perhaps spend some time to go through these basic dimensions, all these things, and try to make yourself aware of what we are referring here, pi or whatever, because all these Buckingham pi theorem, they are very limited to big group of provings or whatever. For example, P what you are referring to, rho whatever you're referring to. So try to enlarge your knowledge. I would say a knowledge storage for all these dimensions, and then should be fine. Is that all right?
Yes, sir.
Okay. So any further question before I let you go? From others? Anyone? Anything you want to ask further? Or so? Yep. Why so quiet? Okay. Yeah. Okay. Good. Yep. Thank you. I think if no question, I will stop here. and I will see you on Monday. So again, I don't think I need to brief against the rules and regulation for your test, right? Again, please turn on your webcams all the times and be sensible, okay? Be sensible for that. I don't want to repeat all the time. You are not first time taking exams, right? Don't take advantage for that. This is only my words. And you know myself is totally against all these plagiarisms and cheatings. Okay? Okay, sorry, I forgot about assignment 2. Yes, we have assignment 2. Tomorrow's night, I'm going to post assignment 2. So again, assignment 2 can be in a group works, maximum 3 students in the groups. Either you want to form between group 1 or you want to form with group 2, I don't really mind, just like your assignment 1. And I given you 1 week plus until tomorrow is 23rd, until 31st. You need to submit before night time. Okay, so tomorrow I will post it. Is that all right?
Yes, sir.
Okay.
Sir, one thing. So for the main parameters, mainly we are gonna have the length, mass, and the time, or anything more than that.
That's why you need to go through. Anything can happen. Okay, anything can happen. In your slide, you got 7. Am I right?
Yes, sir.
7. Is it 7? That's anything can happen. You just get ready yourself.
All right, sir. Thank you so much.
Okay, good. Any other question? Will be a group assignment. I answered that question. Am I right? No, that's the only assignment left. Assignment 2. Either you want to do it individually or there's a group. I leave it to you to choose. So once you finish the test 2, once you finish the assignment 2, and then you are ready for the final. Okay, and I would say that, yep, I think that's all. Okay, good. If no questions, we are going to dismiss here. So again, please stay safe, everyone. Okay, please stay safe. Thank you. Yep, stay safe, everyone. And for those who are not getting your vaccines, right, perhaps register yourself. And yeah, just prepare, just take care anyway. Okay?
Thank you, sir.
Thank you. Yeah, yeah, should be fine. Only on Sunday, perhaps you're a bit tired, but just revise as early as you can. Okay? Good. So if no question, I will leave the class as well. Okay?